Hello again. So what we're going to do today is we're going to talk about the angles in triangles, right? So triangles, as we know, have 3 angles in them, right? But we're going to speak specifically about, what can that help us figure out about the triangles, right? So the first thing that we're going to need is this Triangle Angle Sum Theorem, right? We're not really worried about the name as much as we are what it's telling us. So what this is saying is that the angles in a triangle, when you add them all up, they will give you 180 degrees. Right? You may have heard that before, right? There's 180 degrees in a triangle, right? So what we're going to do is we're going to use that fact to help us figure out some missing angle measures in these problems, right? So this first one that we're looking at, right, we've got some angles that are given, and then it's asking us to find angles 1, 2, and 3 in there, right? So a lot of times what's best to do is to start with the angle labeled 1 and then keep on going after that, right? So let's take a look. If I'm trying to find angle 1, right, I'm looking in this triangle specifically, right, the one that I just kind of outlined there. To figure out that missing angle measure, I need to remember, like, all right, it's all going to add up to 180 together. So if I have 28 and I have 82, right, those are already kind of taken up, right? They're taking up part of that 180. To figure out the measure of angle 1, what I'm going to do is I'm going to start with 180, and I'm going to take away those pieces I know. So I'm going to subtract 82, and I'm going to subtract 28, right? When I go ahead and do that, right, and you can use a calculator to double check, right, I'm going to end up with 70 degrees, right? So 70 degrees is what I'm going to get as my measurement for angle 1. Right, what I would suggest on these is, I know that the diagrams can be a little bit cramped sometimes, but if you're able to try and squeeze it in there, right, where it's supposed to go, because it'll make your life a little bit easier as we try and figure out more of these angles. Right. After that, we're going to try and find out the measure of angle 2. This one's going to be not too bad, especially if you remember what we were doing a couple units ago with angle relationships. So if I'm looking at angles 1 and 2, right, here and over here, those are vertical angles with each other, right? They're on opposite sides of that one intersection between those two lines, right? So if angle 2 is vertical from angle 1, then that means that it is also going to be 70 degrees, right? Because vertical angles are the same measure, right? Last but not least, we're trying to find the measure of angle 3 over there right on the side. Let me zoom in a teeny tiny bit. So when we're trying to get angle 3, we can now actually do that, right? Because we know 2 of the other angles in this rightmost triangle, right? So same thing as number 1. I'm going to start with 180, and I know that I've already used up 70 degrees for that angle 2, and I already have 68 more degrees from that other given angle. And if I subtract all those out, I'm going to end up finding that angle 3 is 42 degrees, right? A good way to be able to check your work is then add them all together, right? In this first triangle, what you could do is you could add 82, 28, and 70, see if they come out as 180. In the second one, you could check out 68, 70, and 42 and see if those add to 180. If they do, then you're all set, right? You found angles that actually do work for those triangles, right? So what I'd like you to do is pause here, try out the second one here, right? It's not all that different, right? And actually, we're going to be using a lot of the same ideas. So pause here, give it a shot, see what you get. So hopefully you gave that a go. Let's take a look. So to find the measure of angle 1, right, again, my suggestion is start with 1 and then see if you can figure it out from there. For the measure of angle 1, same thing as on the last one. We know that it's 180 degrees in that triangle altogether, but I already know about 43 of it, and I already know about 74 of it, right? So I'm just going to subtract those right out. What's going to be left over is what angle 1 is, which is going to be 63 degrees. All right. Same thing after that for angle 2, right, as it was on the last problem. The measure of angle 2 is going to be pretty simple. 1 and 2 are vertical angles with each other, right? So that one's also going to have to be 63 degrees. All right. And again, putting it in the diagram is, you don't have to do it, but it might make your life a little bit easier as you're like puzzling these out. Measure angle 3 to finish things off. Same kind of idea as angle 1. I have 180 degrees total. I know about the 79, and I know about the 63. Right? So if I go ahead and subtract that down, I'm going to end up with 38 degrees left over. Right? And I know that it seems like I'm flying through this subtraction. You're like, wow, Mr. Pog, you're so smart. Look at those subtraction skills. I did it out ahead of time so that I wouldn't get stumbling over my own words here, right? But again, use a calculator when you're doing these out, right? That's what I did when I did them, right? It's better to be better safe than sorry, as they say, right? It's not gonna hurt, right? So, this is all fine and dandy when they give us, numbers for everything. Sometimes we might just have some variables floating around. So I've got all these different pieces of this triangle. What I want to do is I want to figure out what x is and also figure out what the measure of angle A is. So the way that I'm going to do that is I'm going to treat this just like any other triangle. I know that all three of those angles, when I add them together, are going to give me 180 degrees. All right, so I'm going to take 9x, I'm going to add on the 8x, and I'm going to add 129, and all together, those three give me 180 degrees, flying all around the place. Sorry about that. So what we're going to do here, right, is solve it out like any other equation that we would normally be doing, right? I'm going to combine some like terms, right? I've got the 9x and this 8x over here. When I add those together, I get 17x plus that 129 equals 180. Right? After that, what I need to do is, again, just solving it out like we would normally. Move that 129 over to the other side. So 17x is now equal to 51. And then last but not least, divide by 17 to help us get rid of that. And x is going to be 3. Right? So we found out what x is, right? Honestly, if you got to this point and you're like, oh yeah, no, I found out that x is 3, and then you moved on, I probably wouldn't mark it wrong. Don't tell anybody, right? It does want us to figure out the measure of angle A, right? But that's the easy part, right? I trust that you guys can plug in 3 and get that 9 times 3 gives us 27 over here, right? Like that's not the most super important part, right? The most important part is knowing, they add up to 180. This is how I can set up an equation to figure out these missing pieces, right? If you did want to check your work, it is a good idea to plug this in, see what all the angles are going to be, right? And then just like I was mentioning before, if you add those up, hopefully 129 plus 27 plus 24 will all add up together to give you 180, right? So if you ever wanted to check your work, which is not a bad thing to be able to do, right? That's what you do, is just add them all together, see what you get, okay? So we're going to flip on to the second page there. We're going to try out another one that's pretty similar, right? Looks a little bit worse, I know, but the idea is the same, right? So what I'd actually like you to do is pause here, give it a shot, see if you can figure out what x is. All right, so hopefully you gave it a go. If not, give it a shot. It's not going to hurt, as I always have been saying. I feel like I say that every time. So I'm going to take 8x minus 8, and then I'm going to add on the other angle, 2 plus 3x. Then I'm going to add on that third angle, 65. Those three angles all together are going to have to give me 180 in this triangle, right? So now that we've got this set up, I can kind of actually ignore the triangle for a little bit. I'm just going to solve this out. I have some like terms that I'm going to combine, right? Those x's can smush together. All these other numbers on the left side of the equal sign can also smush together, right? So the x's, 8x plus 3x will give us 11x. For the numbers, negative 8 plus 2 plus 65 is going to give me plus 59 there. Right? It still equals 180 on the other end. Right? After this, we're almost there. We just got to subtract 59 from both sides. Get that 11x equals 121. And then divide by 11 to get rid of that. All right, so x is going to be 11. Right? And again, once we get that x is 11, that's really the most important part, right? That's what we're mostly going for, is how can I set this up? Can I set it up and then also solve it, right? If I did plug that back in, what I'm going to find is that the measure of angle A over there on the right is going to be 35 degrees, right? If I plugged it into the other one just to be extra super sure and check my work, I'm going to get that should be 80 degrees. If I add all three of those angles up now, I will get 180, which again is a good way to be able to check my work. Okay, so hopefully this is pretty okay so far. We are going to pivot a little bit and talk about these things called exterior angles and interior angles, which, again, might sound familiar from what we've done in the past on angle relationships. Right? So when we're talking about an exterior angle, right, it is an angle formed by one side of a triangle and an extension of another side, right? So the exterior angle that I'm going to put on the diagram, I'm going to do in red just to kind of color code things. The exterior angle is this one, right on the outside, right? It's made up of that left side of the triangle and the extension of that bottom side, right? And if you wanted to, I know that you can't color code if you're writing in one color, but if you want to write exterior, that's not a bad idea. As far as the remote interior angles go, right, they are angles that are, on the interior, right? They're on the inside of the triangle, and they are further away from that exterior angle, right? They are not adjacent to it, right? So the remote interior angles would be these ones where I'm putting the blue marks in, right? I'm just going to zoom in on the diagram real quick just to fill that in. These are the remote interior angles over on this side. All right. So why are we talking about those? It's for this exterior angle theorem down here. Right? So what this is saying is that the measure of an exterior angle, it's going to be equal to the sum of the two remote interior angles across from it. Right? So if you're looking for the measure of an exterior angle, like that one in red, you can add the two that are in blue that are kind of far away from it. Right? That will work every time for a triangle. Right? So let's practice with that a little bit. What this wants us to do is find the measure of angle DBC, which is this one over, let's try that again. This one over here, that worked much better. If the measure of angle A is 43 degrees, and the measure of angle C is 59 degrees. Right? So if we have 43 and we have 59, we're looking for that one on the outside. Right? So because it's an exterior angle, and we have those remote interior angles, what this is telling me is that if I take 43 plus 59, right, and again, sorry for the bad handwriting, tablet's fighting me a little bit, then that's going to give me the measure of angle DBC on the outside there, right? So let's just add them together. 43 plus 59 is going to be 102 degrees. That is the measure of angle DBC, right? And that's all we got to do, right? Once you figure that out, if it makes you feel warm and fuzzy inside, you can add in that part to the diagram, make sure that that's 102 over there, right? And that's all we got to do, right? What I'd like you to do is try out the next one. So, hopefully you gave it a shot. You might have found that it doesn't give you quite the same information that we had before, right? It gives you something a little bit different. So we still want to find the measure of angle DBC, right? This one that's along the outside there in red. What it gives us is that the measure of angle A is 76 degrees over there, and then the measure of angle ABC is 21. Right? So we can't just add those together to get the angle in red, right? Because they are not the remote interior angles, right? The other piece that we need is this angle up by C, right? So a couple different ways that we can approach this one, right? And either one is fine. One way that we could do it is we can use what we were doing on the front side of these notes to figure out what angle C is, right? So let's take a look at that way. The measure of angle C is equal to 180 minus those pieces we know about, the 21 and the 76, right? That's going to leave me knowing that the measure of angle C is 83 degrees, right? So if I know that that's 83, I know that that other one is 76, I can add those together to get the measure of DBC. All right, so the measure of angle DBC is going to be those remote interior angles added together. So that's 83 plus 76. Right, and at the end of the day, it's going to give us 159, which actually I'm going to color code a little better there. 159. right? So that is one way that we can, use what we've learned to figure out what that missing angle is that they're asking for. The other way that we could do it, right, and it's a little bit, maybe less intuitive, but it still works, right, is that if you're taking a look down by that 21-degree angle that they gave us, right, that 21-degree angle and the red angle that we're looking for, those make a straight line. We know that a straight line is 180 degrees altogether. So if I took 180 and subtracted 21, that's also going to get me 159, right? So you can also use the fact that you have linear pairs, which is something you haven't heard for probably a while, right? If they make a straight line, they add to 180, and you can use that as a way to solve for missing angles as well. Okay, so I'm very worried that I'm going to be talking for way too long on this one. So what I'm going to do is we're going to talk through 7, we're going to talk through 9, and then for 8 and 10, I'm going to have you guys check on the notes that I'm going to upload right after I record this. I'm going to do them out and kind of talk them through, and if you still aren't sure, ask about them, right? That's what I'm here for. So for number 7 here, we're trying to find the measure of angle C, the measure of angle ABC, and the measure of angle DBC. It wants us to find a whole bunch of stuff, given those measurements that are on the screen right now. So measure of angle A, they're telling me is 25 degrees. Measure of angle C over here is x plus 15. Then the measure of angle DBC on the outside here is 3x minus 10, right? So what we're going to do is we're going to have to set something up so that we can solve and figure out what that x is, right? Because otherwise we won't be able to figure out those other angles. So the way we're going to do it is we're going to treat those other angles just like we did on some earlier problems with the variables floating around. So what I have is I have these two remote interior angles, right? I have x plus 15, and I also have 25. If I add those remote interior angles, they will give me the exterior angle, 3x minus 10, right? So again, not doing anything different than what we were doing on the last couple problems, right? It's just that now it's got some variables floating around in it, right? Not too bad. So from here, it just turns into an algebra problem. I can actually just kind of ignore the triangle for a bit again. I've got some like terms to combine, right? I've got a 15 and a 25 over there. So it's going to be x plus 40 equals 3x minus 10. Right? And then just solve it out. Right? We're going to move our x's all to one place. So I'm going to move mine over to the right. So I get that 40 is equal to 2x minus 10. Now I got to move that 10 away from the x's. So we're going to get that 50 is equal to 2x. And then last but not least, chop them in half. Right, divide by 2 on both sides to get that 25 is equal to x. Right? And again, if you're able to get to here, that's really what I'm focusing on as far as, like grading and all that stuff, right? Is can you set this up using the correct properties and can you solve it out, right? I know that you can plug stuff in afterwards, right? We've done that before, right? But see if you can at least set it up and solve it out and get to where we're trying to be. Right. If I was finishing this out the way that it's asking me to, I'm trying to find all those other missing pieces. Right. So if I know that x is 25, then this x plus 15 that's up in the right side of the screen, 25 plus 15 will give me 40 degrees there. Right. If I know that that's 40 and the other lower interior angle there is 25, if I add those together, I know that this one on the outside should be 65 degrees. Right? We could also get that by plugging the 25 in, right? 25 times that 3 is 75. Take away 10 gets you to 65. And then last but not least, if we were really, really trying to overachieve here, right, we could do, 180 minus 40 minus 25 to figure out that other inside angle is 115 degrees, right? Again, using the same properties that we've been working on with a couple different problems so far. Right, so again, I am going to skip over number 8 in this video just to make sure I'm not talking at you for like 45 minutes. I'd like you to try it, and then again, check it on the notes that I'm going to post to our Google Classroom a little bit later after recording, right? So we're going to skip down to number 9. Whew, what a doozy this looks like. So we want to find out all of those missing numbered angles, right? So 1, 2, 3, 4, and 5. So again, what I would suggest is start with angle 1, right? So to find the measure of angle 1, we just got to look at the diagram first and see, like, all right, what do I got? So, and be very careful when you do this, right? Whatever you're watching this on, kind of like turn it upside down and then take a look at this triangle setup right there, right? It looks pretty darn similar to what we were just doing on number 7, right? We've got a situation where we've got these two remote interior angles and then this exterior angle on the outside of there, right? So what I can do is I can use that property. I can say, all right, I've got 50. I'm going to add 78 to it, and then that's going to give me the measure of angle 1, right? So 50 plus 78 is going to give me 128 degrees, right? So again, all we did was we used the same property that we were using on the last several problems, right? That helped us figure out that 1 is 128 degrees down there, right? So after that, then we're going to try and figure out the measure of angle 2. Right, so the measure of angle 2, again, we're going to take a look and we're going to see, like, all right, what could we work with? And again, as usual, there's a couple different things we could do. So I'm going to zoom in real quick. One way that you could do it is, that angle 2 is vertical with this other angle where I'm putting the blue dash in, right? You could figure out this one over here by, saying 180 minus 78 minus 50, and then it's vertical with 2, so you could get it that way, right? It's perfectly fine. A slightly faster way to find it is to note that the 128 that we just found makes a straight line with angle 2, right? They make a straight line together, so they have to add to 180. Right, so what I'm going to do here is I'm going to take 180, oops, if I can get the screen to stop jumping around on me, 180 minus that 128 is going to leave me with 52 degrees. I'm going to try and color code this as best I can, so it's hopefully a little bit easier to follow along with. Right? So 52 degrees there. Right? So that's what angle 2 is. Right? So after we get that angle 2 is 52, right, what we're going to do after that is we're going to go after angle 3. Right? A couple different ways, again, we can get the measure of angle 3. We could go all the way around. We could say, like, all right, I can figure this out because I know that there's 120 there, and then, what that will be with 3, and all right, there we go. But, again, be very careful when you do this. What I'd like you to do is turn the screen you're watching this on 90 degrees clockwise, right? So 90 degrees that direction, right? So when you do that, again, we're going to note that we have these remote interior angles and this exterior angle on the outside, right? Just like we were doing on several other problems. So I know that the relationship between those is that if I add up the interior ones, it gives me the exterior one, right? But on here, we're going to kind of edit that a little bit, right? Actually, let me write that up above the diagram there, right? I know that the measure of angle 2 plus the measure of angle 3 is going to equal 120 degrees, right? Because those are those remote interior ones equaling the exterior one. But if 2 is already 52 degrees, right, then what I can do to solve for angle 3 is I would just subtract 52 from that, right? So, again, I know I'm jumping around a little bit. Back over on the left side of things, the measure of angle 3 is going to be equal to that 120 minus that 52 that we get from angle 2. Right? When we do that out, 120 minus 52 is going to leave me with 68 degrees. Right? So that's how we can figure out the measure of angle 3. Right? After that, we got to get the measure of angle 4. And let me tell you, this one's going to be a little bit easier than that was. Let me tell you what. So, again, I'm going to kind of zoom in on the diagram. If I'm looking for the measure of angle 4, right, it's not going to be too bad. I know that it makes a straight line with that 120 degree angle, right? So I'm just going to take 180 and subtract that 120 from it. Right, so I have 180 minus that 120 that's already on the diagram. And then angle 4, bada bing, bada boom, is going to just be 60 degrees. Right? So we're almost there. Okay. Measure of angle 5, last one to go. Right? Again, a couple different ways we could do this. One of the easiest ways that I could think of is, again, be very careful when you do this, is to flip the screen over and take a look at what we've got over here, right? I've got these two remote interior angles, and again, this one exterior angle on the outside, right? We're using that property a lot here. So I know that if I add up that 60 degrees from angle 4 and that 56 degrees that was already there, that should give me that angle that's on the outside, right? So let's do that, right? Let's take 60 plus 56. That's going to give me a solid 112. Oh, sorry, 116. Don't do mental math when you're trying to change the color of your pen. So 116 way over there. Right? So we used a lot of different information here, right? We could have used the fact that we have vertical angles. We know that the angles in a triangle add to 180. We used that exterior angle theorem that we've been talking about pretty often throughout this, right? But altogether, I guess my suggestion would be to think of these kind of like a puzzle, right? You're trying to solve out and say, like, all right, what information do I have that will let me get angle 1? What information do I have that will then let me get angle 2? And it's going to be a decent amount of brain power to figure out, like, oh yeah, okay, I can do that, and this is going to be 180 that way, right? But just take it one step at a time, try and find them in order, and if you need help, please ask, right? So with that in mind, I'm going to leave number 10 for you to try out. I'm going to have it as part of the notes that I'm filling in and posting on Google Classroom, and please ask questions if you need to, right? These are not easy diagrams to solve out, right? So if you need some help, ask for it. All right, that's it. I'm going to see you next time. Bye.